So in this video, we're looking at example 3, which is parallel and perpendicular lines. And this is all review from geometry, so we're going to move through it pretty quickly. Up at the top is a reminder that parallel lines have the same slope, but different y-intercepts. And if we look at our example for line 1, 6x minus 2y is equal to 10. When we put that in slope-intercept form, we have y equals 3x minus 5. And then line 2, 3x minus y equals negative 5. When we put that into slope-intercept form, y is 3x plus 5. So we can see that the slopes are the same, but the y-intercepts are different. That's an example of parallel lines. Okay, then next, it tells us that perpendicular lines have opposite reciprocal slopes. Opposite reciprocals mean that we're going to change the sign from positive to negative or from negative to positive, and reciprocal is to flip that fraction. So in B, we have a slope of 1/2 in line 1, and negative 2 is the slope in line 2. 1/2 and negative 2 are opposite reciprocals, and so we see that these lines are perpendicular. And then coinciding lines have the same slope and the same y-intercept. To coincide means that they are actually the same line. So when we look at line 1 passes through the points 8, negative 4, and 3, 5. We're going to find the slope by taking the difference of the y's over the difference of the x's, and we get negative 9/5. Line 2, we have the line passing through the points negative 4, negative 2, and 1, 7, and we get a positive 9/5. So are these the same? Are the lines coinciding? No, they have different slopes. Right? If we look, are they perpendicular? No, they're opposite slopes, but they're not opposite reciprocals. So if two lines are not parallel, perpendicular, or coinciding, then what are they? And they are intersecting at a non-right angle. So I would jot that down up at the top of your notes next to the vocabulary, that these lines in C are intersecting but not at a right angle. They're not parallel, they're not perpendicular, they're not coinciding. So you want to pause the video and try these 4 problems on scrap paper. And once you've classified the lines using their slope, then you can resume the video to check your answers. So in A, we have line 1 in slope-intercept form. We can identify this slope as the coefficient on the x. That's negative 2/3. But line 2 is in standard form. So we can either use our standard form shortcut for finding the slope, or you can put that equation into slope-intercept form. If you put it in slope-intercept form, you'll see that 2/3 is the slope. It's the coefficient on the x. So if we compare those slopes, negative 2/3 and positive 2/3, they're opposites but not reciprocals. So these lines are intersecting at a non-right angle. In B, again, we're starting with the same line 1, negative 2/3 x plus 2. So the slope is negative 2/3 for line 1. In line 2, when we put that equation from standard form into slope-intercept form, or you can use the shortcut for slope from standard form, we get a slope of negative 2/3. So we have the same slope and we have the same y-intercept. The y-intercept is the b, and that's 2 in both lines 1 and 2. So these lines are coinciding. Same slope, same y-intercept. In C, again, we've got the same line 1, and its slope is the coefficient on the x, that's negative 2/3. Line 2, when we put that into slope-intercept form, our slope is negative 2/3. So when we compare those, the slopes are the same, but the y-intercepts this time are different, making these parallel lines. Same slope, different y-intercept. Now for D, we're given 2 points on each line. Line 1 passes through the point 6, 1 and 6, negative 1. So our difference of the y's over difference of the x's is going to be a divide by 0 error. And so line 1 is vertical. It has an undefined slope. Line 2 passes through 5, 3 and negative 4, 3. When we do the difference of the y's over the difference of the x's, we get a horizontal line. The slope is 0. A perpendicular line intersected by a horizontal line, those are going to meet at a right angle. And so the vertical and horizontal are perpendicular.